All right, so we've been talking about systems of equations. So a system of equations, remember, is two equations that are both true at the same time. And when we solve them, we find a point that makes them both true. So far, we've learned how to solve them by graphing. So we can look at something, we can draw a picture, and we can find the point where they cross each other. Okay, and then we've also done it with a table, where you take a look at the table and you find a point that's in both tables. So now we're going to look at a method called solving systems by substitution. Okay, so this one's going to be a little bit harder, but it's not too bad. Okay, it does have a bunch of steps to it though. All right, so you really just got to make sure you pay attention so you kind of get through all those steps. All right, so the first thing that we're going to do, all right, is you are always going to have one equation that says y equals something. So like, see how in this example, the second equation is y equals something? And in this example, the first equation says y equals something. Okay, so there's going to be an equation that says y equals something. So the first thing that you're going to do is you are going to put parentheses around what y equals. Okay, so like this guy, my first step, I'm going to put parentheses around the part that y equals. Okay, then step 2 is we are going to plug the stuff in parentheses into the other equation for y. Okay, so this is called a substitution because this equation tells me that y is the same thing as 2x minus 11. So I'm going to go to the other equation and I'm going to replace the y with the 2x minus 11. Okay, so here's what that step is going to look like. So my first equation says negative 2x minus 6, but then instead of writing the y, I'm going to plug in my parentheses, the 2x minus 11. And then just make sure you go back and finish it. Then there's an equals negative 18. Okay, step 3 is we're going to solve this equation. Okay, so this looks like it's going to be a little bit complicated, but we're going to be okay. So the first thing I'm going to do is a distributive property. So negative 6 times 2x would be negative 12x. Negative 6 times negative 11 is positive 66. And then everything else just gets copied down. So that comes down, and the negative 2x in the front comes down. Okay, we've got some like terms here that I can combine. So I'm going to combine those together. Negative 2x and negative 12x is negative 14x. 2 fires and 12 more fires, right? Plus 66 equals negative 18. All right, then we're going to subtract 66 from both sides. So negative 18 and negative 66. That's going to be negative 84. Okay, and then I'm going to divide both sides by negative 14. It's okay if you can't do this in your head. If you want to use a calculator, that is totally fine. So negative 84 divided by negative 14 is 6. Okay, so you can totally use a calculator for that part, so that's not a problem. Okay, so recap, what have we done so far? We put parentheses around the thing that y equals. We rewrote the other equation, the top one, but we replaced the y with the stuff in parentheses. Distributive property, combined our like terms, and then we just solved like normal. You can use a calculator. Okay, so that's step 1, 2, and 3. Step 4 is now we know what x equals, right? So now what we're going to do is we're going to plug whatever x equals into the other equation and solve. So we have figured out x equals 6. So what I'm going to do is I'm going to go back to either one of these equations. It doesn't matter, right? But personally, I like the second equation better in this one. I think the y equals equation is usually a little bit easier. So I'm going to go to this y equals 2x minus 11 equation, and I'm going to replace the x with a 6. So it's going to be y equals 2 times, instead of x, plugging in 6, minus 11. So 2 times 6 is 12. And then 12 minus 11 is 1. So y equals 1. All right, and then we are almost done. We have one more step, and this is the easy one. The last thing you're going to do is you're going to write your answer as a point, okay? And your point always needs to be x and then y. So just make sure you pay attention to which one's x and which one's y. So my answer, x was 6, y was 1. And that's the answer to that problem. Okay, so that's the point where if I graphed these, they would cross each other. And there we go. Okay, so again, it's a lot of steps, but the more you do these, the easier it's going to get because you're going to get into the rhythm of it. So let's do another example. So this guy right here, I'm going to start by putting parentheses around whatever y equals. So I got y equals 5x plus 19. So that goes in parentheses. Then I'm going to rewrite the next equation, but when I get to the y, I'm going to put the parentheses instead. So negative x plus 3. And then instead of y, I'm putting in the 5x plus 19. And then just don't forget to finish it, equals 1. Okay, we're going to solve this. So distributive property, that's going to be 15x and then 19 times 3. I don't know what 19 times 3 is off the top of my head. So I'm going to just throw it into my calculator. Oh, it's 57. Totally okay if you want to use your calculator. And then I just copied everything else down. Okay, these two are like terms, so I can put those together. 1 fire, 15 buckets of water. That's 14. Subtract the 57 from both sides. So 14x is going to equal negative 56. And then I'm going to divide both sides by 14. I don't know if you heard me, but I just threw that into my calculator. We got x equals negative 4. Okay, so again, if you want to use a calculator for these, that is not a problem. You go ahead and do that. Okay, so now that we've got that part, now I know x is negative 4. Now I'm going to plug negative 4 in for x into either equation. And it doesn't matter which one. Pick the one that looks easier to you. Okay, I think the top one looks easier, so that's the one I'm going to use. So the top equation says y equals 5, and then I'm replacing the x with a negative 4 plus 19. So 5 times negative 4 is negative 20. And then negative 20 plus 19, so 20 fires, 19 buckets of water. That's going to work out to 1 fire left over. There we go. And then last but not least, the easy part, you write your answer as a point. And it's always x and then y. So negative 4, negative 1. If you go in alphabetical order. And there we go. All right, now there are special cases, right? Remember we talked about graphing? We said sometimes you can have no solution and sometimes you can have an infinite number of solutions. Okay, well, let's talk about what those look like when you're solving by substitution. Okay, so when you're solving by substitution, sometimes a weird thing will happen where all of your variables will go away. Okay, so if all of your variables cancel out and whatever's left over, which will just be numbers, if it's true, so like it says something like 5 equals 5 or 12 equals 12, right? Or 4 minus 2 equals 2. If whatever's left over is true, then that tells me that there are an infinite number of solutions. Okay, but if all of your variables cancel out and whatever's left over is false, like it says 10 equals 3 or 5 minus 1 equals 7, right? If whatever's left over is false, then that means there's no solution. And it's actually really nice when these when they come up, because you get to kind of shortcut the process a little bit. Okay, so let's take a look at how those are going to happen. So first thing I'm going to do is put parentheses around what y equals. Okay, and then I'm going to replace the y in the other equation with that parentheses. So my second equation is 2x minus, and then I'm replacing the y with 2x minus 1. Don't forget to finish your equation, equals 0. Okay, so to solve this distributive property, that's going to be a minus 2x and then a plus 1. Distributing a negative just changes the signs of everything. And then here, right, these are my two like terms, but when I combine those, 2x minus 2x, that's just 0. That just goes away. So I'm left with just 1 equals 0, because these guys cancel each other out. Okay, so all of my variables canceled, and what's left, does 1 equal 0? No, it doesn't. That's not true. So all my variables canceled, what's left is false. So that tells me that there is no solution. And And like I said, it's kind of nice when that happens because look at how much work we got to skip. All right, so let's take a look at the other one. Spoiler alert, it's going to be an infinite number of solutions. Okay, so parentheses around this part. I'm going to rewrite the second equation, but when I get to the y, I'm putting in my parentheses. Don't forget to finish your equation. Okay, and then we're just going to solve this. So I'm going to start by doing a distributive property. So 2 times 6 is 12x minus 2. Copy everything else down. Okay, and then here, the negative 12x and the positive 12x, they cancel each other out. So what I'm left with is I'm left with a negative 2 on this side and a negative 2 on that side. And does negative 2 equal negative 2? Yeah. So all of my variables canceled out, and what's left was true. So this one has an infinite number of solutions. Okay, and what this means is that if you were to graph these two lines, they're parallel to each other. So if you graphed it, your two lines would run parallel. They'd never cross each other. This guy, if you were to graph it, these two are secretly the same line. They don't look like it, but if we were to rework this second equation a little bit, you'd see that it's actually the exact same equation. It just looks a little bit different. Okay, so those are the same line, which means that they always cross each other because they're the same thing. Okay, so that is how you solve a system by substitution. We are going to spend a few days practicing this. So if you kind of feel like, oh man, I'm a little overwhelmed, this is a lot of work, right? We're going to practice it and we're going to get there, okay?